Hello everyone. So today we are going to solve GFG problems. Problem of the day: all subset XOR sum. In this we have to find every subset, and after that we in every subset we need to do the XOR, and finally we need to add. Like suppose if 7 2 is there, what are the subset? 7 2 7 2. Okay, like this 7 2 is there. We need to do the XOR, and finally we need to add all. Like if we see 1 2 3 in this array, also like these are the sub array. In sub array inside this we need to do the XOR and later we need to add. Okay, I'm going to directly go for the optimal solution. Like what we can do for this one is, okay, so I want to know the contributions. Like for this I want to show you a page. Okay, like suppose we have the 7 2 and 1 2 3 is there. Okay, so like this in 7 2 what are the subset is this 7 2 and this 7 2 1 is empty. So for 7 this is okay. So if we need to find the sum of these three, this is 7 XOR 2, that means 5. That means 5 2 and 7 if we need to add. Okay, so how we add? So like there is two way. Okay, like suppose if okay, if we did if how we can add, like we calculate that how many one are at the unit place. So 1 and 2, so 2 2 1 at the unit place, so 2 times, okay, count it 2, so 2 times 2 to the power 0, and this is 1 just for like if this bit is 1 or not. Okay, so there is no required, but okay, so 2 into 2 to the power 0, that means 2 into 1, that is 2. Okay, this is 2. Okay, now for this section, okay, 2 1 is there, so this both is going to contribute, but what is the place value for this? This is 2 to the power 1, that is 2, so 2 is going to contributed by 1 and 2 is going to contributed by this 2 plus 2, that is 4. Okay, now if we talk about this one, what is going to contribute this thing? This is going to contribute 4 and this is 4, so that means 4 into number of time, that is 4 into 2, that is 8, and if you are going to calculate, then that is 14. Okay, now if we see, okay, so if okay, now one is going to contribute. Okay, so if any one is there in anywhere, that is going to contribute, so the things that should come in our mind is or. Okay, whenever do the or, if anyone is there, that would come in this here. So what we are going to do, this one is there, this one and one. Now 1 into its place value into how many times, this is the whatever the things that I have done. Now our question is how to do this count, right? And this is the core things. Okay, so like okay, so the thing is like if any bit appears, that means if there is any one and you are going to find all the subset, then that is going to be totals half of the subset. That means total is 2 to the power n, then 2 to the power n by 2, which is 2 to the power n minus 1. So if you see in any number like 7 or 2, if suppose this is 1, okay, if you see in any element 1, then odd is going to give you 1, and this also going to tell you that this there would be uh, 2 to the power n minus 1 subset which have 1, like 2 to here 2 to the power n minus 1 is n is 2. Okay, so this become 2 to the power 2 minus 1, that is 2 power 1, that is 2, so 2 1 is there. Let's see, 2 1 is there here also. If you find 1, okay, here you find 1, that means 2. Okay, so this is the thing. Like if you take another example also, the same is there. So only thing is like, now what I want to show you, like 1 into 2 to the power 0, 1 into 2 to the power 1, 1 into 2 to the power, and count is everywhere. And if you remove count, that is if you take common the count, like here I have taken the common. So now what this is nothing but exactly the or. Okay, if 1 is there, then we are going to go to power 0. Okay, if not, then if 0 is there, that thing, then they is not going to contribute anything. Okay, now so as I said, like this is exactly the or and this is the count. Okay, so we are just going to return this. So if I write the code, the things will be more clear. Okay, so whatever the first things I need to do the or. Okay, so int n equal to array dot size. Okay, so now I'm going to calculate or. Total or equal to 0, and this is going to total or equal to array of I. So this is going to give us the total. Now the thing is we have to multiply it by count. And what is the count? So if we return, okay, if we return like what that is, total odd into now the count. So what the count is, as we see, this is 2 to the power n minus 1. So what this is, 2 to the power, okay, power of 2 to the power n minus 1, right? Okay, so this is going to run, but what is like this thing, this looks complicated. Okay, what actually it means, like if we see in, this is also fine. If we see like, okay, this is our answer 14, or like this one 12 is answer, which is 1120, and this odd is 11. So actually if we multiply by 2 to the power 2, that means it is nothing, just the left shift by 2 digit. So whatever this n minus 1 is, that means we are doing the left shift. Okay, so either you write this one, or we can write left shift of this. Okay, sorry, this is left shift of n minus 1. Okay, so now if we run, okay, and if we submit, okay, it's got passed. Okay, so if we talk about the complexity, we have just moved to one loop, that means log of n. Thank you.